All right, guys, welcome back. So as you can see, I have my maglev set up. I don't have the magnets in yet because I'm still trying to work out the distance this back plate has to be. So I tried doing spacers with 2 washers. It turns out I'll need 3 washers in between each one. And I'm using a piece of non-magnetic metal as the back plate because I noticed Sky uses metal on his, and I think that'll help this to grip better. And this is, of course, 304 stainless steel, non-magnetic. And so I need to, again, bring this out by the width of a washer. I was going to try to 3D print something, but then I realized that the plastic can be compressed, and over time it would lose the it would lose its thickness or its strength. And I need to fix the back plate on this one. This one is working fine, as you can see. This one's got a wobble issue, and I can't have that. Can't have that thing wobbling unless I don't have, because Sky was telling me that in order for a maglev to work properly, both ends can't be touching the plate. Only one end touches the plate. And if I can get just this end to touch the plate, then I'm fine. So if I put some space, if I put in a larger spacer in between here, I think I can get that achieved. And I still have my HHO set up over here. I haven't forgotten that. So I'll be right back. Stay tuned. So quick reference note. I'm not sure if you guys know how hard it is to set this up, to get it so that I can bolt it down, because these magnets want to repel. The bar magnet that's on the end there, the ring magnets here, it is really tough. And once you get it in there, then it's okay. Then it stays in there. But to get both of them, oh my God, it's a pain in the butt. I definitely need to cut these off and put little caps on there, because I have to hold it like this when I'm doing it and pushing it with my thumbs at the same time, pulling it in this way well, first I capture this side, and then I try to capture this side. Oh, it's rough, and it's rough on the hands, especially with these things sticking out. Anyway, just thought I'd throw that in there. Anyway, stay tuned. So remember when I said I have to add a spacer here? I don't know if anybody was quick enough to catch that, but no, I don't add one. I got to take one away to bring this closer in. I don't know what I was thinking. I just did all this work for nothing. Like I told you, it's a real pain getting this in here. Anyway, now I got to undo it and not add one, but take one away. Actually, probably take 2 away. Stay tuned. All right, so I think I have it. I've got it running pretty good now. I still don't have the magnets in it, so that's still to be seen what would happen when I put the magnets in. But it seems to be doing pretty good. I have it right justified to avoid the super wobbly side, but it's nice and sturdy in there. I've got large magnets for the shaft. I don't know if you can see. There's a very small gap between the OD and the ID of these 2 magnets. Oh, I got to get this guy out of there too. This guy is definitely going to influence something. But yeah, let me get the magnet in there, the magnets in there, and let's see what we got. Stay tuned. Whoa, whoa, whoa. I'm going to have to mount this thing a little bit better. I just did a test. I just fired it up with my new coil, and it's pretty dangerous. I'm going to have to, thank God this has got a potentiometer on it. but I'm going to have to probably start off at a lower voltage because it was scary, but it runs good. It's loud because it's not balanced properly, and the back plates I have is not good. I'm going to have to change that out, but it is working. Stay tuned. So it is flying, and I only have it on 8 volts. So the problem is, yeah, it's making a lot of noise, but it's going really well. I attribute it to the 304 stainless steel, my new coil, and this killer circuit, the Sky circuit. Yeah, I got to get a better back plate. That's the whole problem. The back plate, it's just not cutting it, but man, it's flying, especially for only 8 volts. Let me turn it down a little bit. There's 6 volts, and this isn't even tuned. I don't have the Hall sensor in the right spot. So that's working out really good. 6 volts. And it is flying. Now it's doing well. Still putting out some decent output. Oh, if I pull see, this is what surprises me about the Hall sensor circuit. If I pull the coil back, it actually speeds up. Yeah, she's flying now. I have to figure out the back plate. That's what's causing all that racket. You hear how it speeds up when I pull it back? Very cool. I can't believe I finally got it work. Well, I've had maglevs work before, but I've been working on, ooh, there it goes, nice. See, I'm using the metal because I think it's a smart thing, and Sky uses it. I think once it digs in and it finds a spot, like it has now, yeah, she's flying, and that's on 6 volts. 6.97 volts. But again, the Hall circuit isn't even the Hall chip. I just put it in the corner of the coil here because those magnets are really powerful. I only have 2 in there. Yeah, it found a spot. Let me turn it up a little bit. That's 8.4 volts. Yeah, no, let me turn it back down. It doesn't like that. It likes 7 volts. Oops, I pulled the... Come on. Yeah, so it was going really good there for a little bit. I've got to secure the rotor to the shaft better because it's not, I wouldn't call it loose. See, I went down to try to adjust the pot to see what was going on with it. Let me try firing it up again. It'll auto start too. See, it auto starts, and I think I've got to get it going faster to get that. Oops. What happened? I blew some, oh, the Hall chip came out. Anyway, I got to change the back plate. I have to figure out something to use. And I know that metal is the key. You guys heard how it started humming, how it was doing really well there for a moment. That's because I think the hardened end, the point of this shaft dug into the metal and found its spot. I wouldn't say dug in, but you know what I mean. Let me see if I can get it to auto start again. Yeah. I don't know why it's doing that now. Come on, catch. I think it's because, is it? Yeah, I think it's because it's somehow left justified. All right. Anyway, it was going good there, right? You guys saw that. It was going really nice there for a moment. Really nice at 7 volts. I don't dare bring it up to 12. Let me see what I can do to fix this. See if I can't get it going again. Stay tuned. So depending on whether I push this, if I push this in, let me slide this out some. Oops. Come on, get in there. Can't get it to do like it was doing before. There it goes. Come on, come on, come on. Yeah, it's making a racket. I'm going to have to fix the back end there. Let me shut it down. Yeah, it's definitely making a racket because the back plate is not good. Everything else is perfect on this thing. The shaft, the rotor, the bearing ends are not even glued. They're pressed fit with the, oh, you know what it might be? I noticed that when I ground down the shaft here to get it to a size that will allow the magnet to fit on it. I don't know if you guys, if you didn't see the last video, I explained it in the last video. I made a step down, so I ground it down. One of the ends I noticed wasn't quite centered. And I don't know how that happened because I was grinding it down in my lathe, my wooden lathe, my homemade wooden lathe, that bad boy down there. But I think what happened is in order to get it started down to a smaller shaft, I had to cut into it, turn it, cut in, turn it, cut in, and then cut that off. And I think when I did that, I didn't do it careful enough. Anyway, I did have this thing humming at one point, so that means I know I can get it going. I just have to make sure that I get it left justified or right justified onto this. And so the next trick is to take this last spacer out, which will push it more that way, and force it into a more equal balance point between being pushed out and pushed in. And once I get there, then it will want to right justify because I'll leave this one alone. This one's pulling it in. I need for this one to be almost pushing it out, but not quite. All right, let me get going and see what I can do. Stay tuned. Oh, really quick, I just wanted to admire this coil I made. It came out so nice. I think I have like 5, 6, 7 layers. I don't know how many wines are on each one. I don't really bother for all that. I mean, I could count this and tell you how many wines are on there. But I don't really care for all that. That's just a reflection. It's not a drop. I thought it was a drop. But man, this coil came out super nice. Anyway, let me get back to work here instead of playing around. Well, that's what I am doing. But anyway, stay tuned. Yeah, so I was still able to incorporate 3D printing onto this shaft. So the step down is right here, and I 3D printed a hat type sleeve that fits over the outside of this, but allows this to butt right up against the edge of this, the edge of the shaft. And then this piece here, this isn't even glued. This piece here gets press fit on. I made it purposely too small so that I could change these out without having to deal with glue. I thought that was a cool thing that kind of happened by accident. And I printed out 2 more of them, which are a little bit smaller, thinner in the wall, but still nice and tight. I was going to swap these out because I also wanted to work on the shaft, which I still may do. I want to clean up the point here and make it smoother, not round, but still pointed. Anyway, what was I doing? Oh yeah, I got to take these out, which will take these spacers out, which will push this back plate in closer, which will justify the shaft. All right, stay tuned. So really quick, this is what the back plate looks like. This is a non-magnetic metal. I think it's aluminum. I'm not sure. Yeah, I'm pretty sure it's aluminum. And basically, it's a little concaved, and I did that on purpose. I took it, I cut it out of a piece of aluminum that I had. Then I brought it over to my anvil. And first I beat this piece of wood down so that it was a little concave. Then I put the metal in there and hit it like that and got it to concave. And then I sanded it. So it looks rough, but it isn't. It's nice and smooth. But it is a little concave. And again, I did it on purpose to keep the shaft in the center of it. And what I also forgot to do is, and I'm not going to forget on the next run, is to mount a magnet on this side here to help justify the shaft. Because I've done that before on my maglevs. You can see that little maglev right there. You can see the magnet on the outside there. I also did it on that maglev there. And I also noticed that Sky does it too. But I think you only do it on one side. That's to justify it. Because it doesn't need it to hold it up. Because these 2 ring magnets and this large ring magnet do the trick. Anyway, let me get this thing going. Stay tuned. It's a little bit better, but it's too stiff. Wait a minute. Let me turn that off. All right, let me bring you back in a second. Hold tight. Now I got it right out of the gate, and that's at 11 volts. Let me turn it down a little bit. There's 10 volts. Now it's humming beautifully. Sweet, huh? Putting out some nice voltage. Whoops. Come on. Oh, it lost the dagnabbit. Whoa, 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 whoa. Wait a minute. Let me turn it off. What happens is I don't have this. This thing can slide in and out, and what I need to do is make it so I can put it in, lock it down, slide it out, lock it down, because when it moves like that, it messes it up. So let me figure out some way to do that, then I'll bring you back. But you guys saw that was beautiful. All right, hold tight. All right, so I definitely got it on the run. So I know what I need to do. I need to fix the back plate. I have another shaft. What I may try to do is recreate this shaft again, but this time maybe I'll just maybe I'll go back to my ball end on this shaft, but using the 3D printed parts like I used to do. I don't know. I'm going to have to play around with this. But I did get it going. So I'm happy about that. I love this new coil. The shaft is the way to go. But look, you see that right there? See how that's the shaft itself. The end of it, the very end, because it's right justified. It's not. Anyway, I think that's enough for today. I think what I need to do too is take this spacer out so that I have a more even, so the balancing point is more in the middle, not pushing it too far to the right, not pushing it too far to the left, but in the middle. I think that's where it floats the best. I think that's why I got those 2 good runs, because I had it, because I'm seeing this here, and this can come out some more. Let me try that really quick before I call it an evening. Stay tuned. Yeah, so the ticket was not to have spacers at all. It's flowing really nice now. Now, the issue is, it's going to have, and I've already noticed it when I took the back plate off, the shaft had started digging a hole. And that's okay. That's kind of what I wanted it to do. But that's moving nice and free now. And it is right justified, which is what I wanted. Yeah, let me see if I can't fire it up one more time before the evening ends. Stay tuned. There it goes. That's at 10 volts. Still a little on the rough side. There it goes. I knew it would catch. It's just a matter of it digging that hole in the right side. Come on, baby, just hum. There we go. There we go. All right, that's enough. That's enough. One of the problems is I didn't mount down the circuit, so it slides all over. I did finally mount this guy down. But I forget, I do one thing and then I forget another, but yeah, this thing works really good as long as it stays right justified. And that's the secret of a maglev. It shouldn't be pressing up against both plates. One side should be floating and it presses up against the other side. That's how all maglevs work. And I somehow forgot that. But this circuit is a killer circuit. And this coil is really nice too. All right. I'm going to still work on a better back plate. But now that I know how deep to go and what the thickness of the plate should be, it should go a lot smoother once I find a material to use. I'd like it to be flat and slightly concaved, but that concave thing introduces a lot of room for error. So we shall see what we shall see. Ciao, ciao.